Next, we have Amat Bamba Mbake, professor at UCAD ESP Dakar. If you can, oh, great. And he'll be talking to us about experienced learning with Project Tolbi. Okay.
Thank you. Okay. Good evening, everybody. I have a strong voice, so I will try to wake you up all. Maybe you will have to make some nightmares later on. So today I'm talking about our project, Tolbi. And I think I will try to change my strategy and not talk about our wins, but about our failures and what we did wrong and the best 100 ways to make a project go wrong when you talk about agriculture and also public data, not only digital public goods. So Tolbi is first of all an agri-tech that has been created inside of the university, inside of Université Cheikh Anta Diop. During our courses, we try to help students develop projects using IoT, for example. And some of those projects have to be deployed on the field. And one of those projects was just to create a sensor that can help a watering system to make more intelligent decisions. Well, I will go faster a little bit because I have only 7 minutes. So what we had to do was try to create a system that will help the watering system be more intelligent, help also the farmer to produce with more profitability, but also using ICT. However, we made multiple mistakes on the way. What you see in the middle is the first version of the sensor we have deployed. What we can understand just from that picture is that we put that sensor on the soil to measure, for example, the humidity of the soil. However, what did the farmer do from the first day? Water it. It was just as simple as that. We said, well, we have maybe made a small mistake. We put it too low. It wasn't really visible because of the grass all around. And we couldn't see that from the lab. Because we were working in a lab, we had a small pot with some sand in it. We put the sensor in it and tried to measure humidity of the soil without being really in the field. We've made a second mistake after that. Students just took the sensor, another version of it, and put it close to the well. What was the consequence? We had false data all along. The system was supposed to talk with the producer, with the farmer, who will be using his phone, and get some messages from an intelligent system that we called SIMCA in a local language. We made two mistakes. First of all, we choose the wrong language. We usually talk Wolof in Senegal, but there are 39 languages that can be used inside of Senegal. We just choose the wrong one. We tried to change. Take Tukulër, for example. However, there are no digital resources to help our system make some speech in Tukulër or in Serer. Something had to be developed. So just from that project, what did we have to do? Change the design of the sensor, make it higher, make it harder, make it more secured so that it won't be, well, we had that problem with rabbits, for example. They came and push it over and so on. So we had to make some more secured technology, more usable for the farmer, that can speak a local language. And all those problems we discovered just because we never went into the field to design a technology to solve some problem. When we continued in our system, we discovered other kind of problems. For example, we used components that were proprietary. We had to buy them to be able to make that sensor, to be able to have a prototype of it. Whenever one of our sensors failed, we had to wait 3 months because they have to be imported from China. We had a smaller budget than what we really needed because there were supplementary costs whenever we wanted to import those components in a short term. We didn't know that the business went that way. We use a proprietary technology. What did it mean? What did it mean for us? It meant that we could not make any modification to the system. We had to use it as it was. So after maybe few failures, we had to change the technology and base ourselves or design on open source technology, open hardware technology, use open source codes to be able to develop the system. We discovered also that we needed assistance of multiple partners. Instead of just walking into our fields, into our lab, we had to go with the farmer, but also with other specialists in agriculture. Other specialists into speech recognition, as we can say. We needed some other specialists into data. We needed multiple skills to be able to develop a sustainable solution. That was maybe 4 years ago. What we discovered also is that even the communication systems we have used were not adapted to the real land. Because of what? What you see here is a map of connectivity in Senegal. So most of the country is not covered by 3G, 4G, and etc. So we even had to change the technology because even the bandwidth where there were connectivity, the bandwidth was not enough. So we had to go and change all our solutions and adapt. But now, we changed the stack. We went further. What we understood is that working in agriculture in a small, at a small scale isn't really helpful to get an understanding of how agriculture works. So we went to a state, well, we went for a crop model solution, and to get enough data to produce these crop models, we had to work at 3 different levels at the same time. We still use the initial sensors we deployed, but we added now drones to collect more data. And we also are working on nanosatellites that will give us a greater view of the fields. So from all of that, what I can say is that even if the solution works, you have to understand that there is an ecosystem with multiple actors, with different point of views and different needs for the system to work and be sustainable. That was all, and thank you.